Hello students, welcome back. Today we'll continue with exercise 4.5 of chapter number 4, Determinants. Okay, till now we have completed till question number 11. So today we'll start with question number 12. Okay, so see, in question number 12, two matrices are given, matrix A and B, and you have to verify AB, product of AB and inverse of it is equal to B inverse into A inverse. Okay, so let's start with 12. A 3 7 2 5. B 6 8 7 9. Okay, first let's find out product AB and then take it out its inverse. Okay, so first AB, this will be equal to 3 7 2 5 into 6 8 7 9. Okay, now let's take the first row, that is 3 and 7. 6 threes are 18 plus 7 sevens are 49. 8 threes are 24 plus 9 sevens are 63. Okay, now second row. Okay, 6 twos are 12 plus 7 fives are 35. Okay, 8 twos are 16 plus 9 fives are 45. Okay, so now this will be equal to 18 plus 49. So that will be equal to 67. 24 plus 63. That will be equal to 87. 12 plus 35. That will be equal to 47. And 16 plus 45. That will be equal to 61. Okay, so this is AB. Now we need to find out inverse of AB. So what is the formula? 1 upon determinant value of AB into adjoint of A. So what is the determinant value of AB? Okay, so 67 into 61. Let me calculate it. 67 into 61. Okay, so that is equal to 4087 minus 87 into 47. So that will be equal to 4089. Okay, so 4089. So this is equal to minus 2, and that is not equal to 0. That means its inverse exists. Now, adjoint of A, sorry, adjoint of AB. We will not find out its cofactor, we will directly use the shortcut. What was the shortcut? Exchange this diagonal 61, 67. Okay, this as it is, but change the sign. So minus, minus. Okay, so now AB inverse. This is equal to 1 upon determinant value of AB into adjoint of AB. So this is equal to minus 1 by 2 into 61 minus 87 minus 47 and 67. Let's name this as 1 AB inverse. Okay, we have solved the LHS. Now it's time for RHS. So what is RHS? B inverse into A inverse. So first we need to find out B inverse and A inverse. So first let's go for A inverse. So for A inverse, what we need to do? Adjoint of A, or let's find out determinant value of A. This is equal to 5 3s are 15 minus 7 to the 14, that is equal to 1, not equal to 0. That means A inverse exists. Okay, adjoint of A. Okay, just exchange this 5, 3, and shortcut we are using minus sign, minus 7, minus 2. Okay, so A inverse will be equal to 1 upon determinant value into adjoint of A, 5 minus 7 minus 2, 3. This is the value of A inverse. Now for B, let's name it as 2. B inverse, I need to find out the determinant value of B, and that is equal to 6 nines are 54 minus 8 sevens are 56. So this is equal to minus 2, and that is not equal to 0. That means B inverse exists. Adjoint of B, we'll use directly shortcut. Exchange the value of this diagonal 9, 6, and 8, 7. Minus sign. Okay, so B inverse will be equal to minus 2. 1 upon minus 2 means minus 1 by 2 into 9 minus 8 minus 7 and 6. Let's name this as 3. So we have found out A inverse and we have found out B inverse. Now we will find out the product B inverse into A inverse. So let's multiply it, B inverse into A inverse. This is equal to minus 1 by 2, 9 minus 8 minus 7, 6. What is A inverse? 1 by 1, that means 1. 5 minus 7 minus 2, 3. Okay, minus 1 by 2, we'll keep it as it is. So now first let's take this row, 9 minus 8. So this will be equal to 1 by 2. 9 5s are 45, minus minus plus, 8 2s are 16. 9 to 7 minus 63, minus 8 3s are 24. Now, second row, okay, minus 7, 6. So 7 5s are minus 35, and 6 into minus 2, minus 12. 7 7 minus minus plus 49 plus 18. So let me erase this. Also here I need to erase it. Okay. So now this will be equal to 1 by, actually it's minus 1 by 2. Minus 1 by 2. 45 plus 16, that is 61. Minus 63 minus 24, that is minus 87. Minus 35 minus 12 minus 47, and 49 plus 18, that is equal to 67. So this is 4. So I can say that from 1 and 4, AB inverse is equal to B inverse into A inverse. Okay, clear? So I'm repeating what we did. First, I found out the product of matrix A and B means AB, found out its adjoint, and find out its inverse. Then separately, I found out A inverse and B inverse, and then take the product of B inverse into A inverse. And then comparing both the equation, I got AB whole inverse is equal to B inverse into A inverse. Okay, so note down question number 12. Now let's move to the next one. In question number 13, there are two parts. Matrix A is given. First, you have to show this, and using this, find out A inverse. See, the question is hence find A inverse. Means you cannot find out directly by using the method like 1 upon determinant value of A into adjoint of A. You cannot use that one. Hence find this means using this equation you have to find A inverse. Okay, so first let's prove this one. Okay, so question number 13. What is matrix A? It is 3, 1, minus 1, 2. I need to find out A square minus 5 plus 7i. So I need to find out A square. So A square will be equal to A into A. 3, 1, minus 1, 2. 3, 1, minus 1, 2. Okay, let's take the first row, 3 and 1. 3 3s are 9, minus 1 into 1, minus 1. 3 ones are 3, plus 2. Now let's take the second one, minus 1 and 2. 3 into minus 1, minus 3, minus 2. Minus 1 plus 2 to the 4. So I get A square is equal to 9 minus 1, that will be equal to 8. 3 plus 2, 5. Minus 3 minus 2, minus 5. Minus 1 plus 4, that is equal to 3. So I got the value of A square. Now let's take LHS. What is LHS? A square minus 5 plus 7i. So A square, that is 8, 5 minus 5, 3 minus 5 into A. So A is 3, 1 minus 1, 2 plus 7. And what is I? That is identity matrix. I will take 2 cross 2. So now 8, 5 minus 5, 3 minus 5 3s are 15. Multiply 5 with each element. 5 minus 5, 10 plus 7, 0, 0, 7. Okay, so this is equal to 8 minus 15 means minus 7 plus 7, 0. 5 minus 5, 0 plus 0, 0. Minus 5 minus 5 means minus 5 plus 5, 0 plus 0, 0. 3 minus 10 minus 7 plus 7, 0, and that is a 0 matrix, that is equal to RHS. Okay, so first part we have proved. Clear what I did? I found out A square. I was already having the value of A, so using it I found out A square. Now I put the value of A square, A and I in this equation and proved that this is equal to 0 matrix. Now we have to take this equation, that is A square minus 5A plus 7I equal to 0 matrix. And then we have to find out A inverse. So what I will do, I will multiply both sides by A inverse. Multiply both the sides by A inverse. Okay, so A inverse into A square minus 5 A inverse into A plus 7 A inverse into I equal to A inverse into 0 matrix. So now I will separate it A inverse into A into A. So A into A square minus, what is A inverse into A? Identity matrix. So this will be equal to 5i plus A inverse into I, A inverse. Remember, any matrix, when you will multiply with the identity matrix, the resultant matrix will be that matrix itself. So A inverse into I will be equal to 7 A inverse. And any matrix multiplied by 0 matrix will be equal to 0. Okay, so now A inverse into A, again I, and I into A minus 5I plus 7A inverse equal to 0. So 7A inverse, I will take on this side 0 minus A minus to plus 5I. This will be minus, this will be plus. So minus A, or I can write it down this as, let's write down 5I minus A. Okay, so now this will be equal to 5. Identity matrix 1, 0, 0, 1 minus matrix A 3, 1 minus 1, 2. So this will be equal to 5, 0, 0, 1 minus 3, 1 minus 1, 2. So this was 7A inverse. So 5 minus 3, it's 2. 0 minus minus 1, minus 1. 0 minus minus, sorry, it's 0 minus 1. So minus 1. 0 minus minus 1 plus 1. And 1 minus 2, minus 1. So this was 7A inverse. So A inverse is equal to 1 by 7. 2 minus 1, 1 minus 1. Okay, so I got this A inverse. I can also multiply this 1 by 7 to all the elements of the matrix, or let it be this only. Okay, we made a mistake here. It's 5 into 5. So it will be 5 minus 2, 3. Okay, so this is A inverse. Clear? So this is very important. This type of sum can be asked in 4 marks. First, you have to prove this equation, and using that equation, find out A inverse. So remember, which step you have to take? Multiply that equation by A inverse on both the sides. Okay, and remember, A inverse into A will be equal to I, and any matrix multiplied by I, it will be equal to that matrix. Clear? So note down question number 13. Now let's move to the next question. Okay, question number 14. Matrix A is given 3, 2, 1, 1. 3, 2, 1, 1. Okay, and the equation, you have to show that, okay, find A and B such that, it's not show that, such that A square plus AA plus BI equal to 0. So first, for that I will require A square. So let's find it out. A square, this will be equal to 3, 2, 1, 1 into 3, 2, 1, 1. So first, let's take the row 3, 2. So 3 3s are 9 plus 2. 3 2s are 6 plus 2. The second, 3 1s are 3 plus 1 and 2 plus 1. So now A square is equal to 11, 8, 4, 3. Okay, now this is given. You don't have to prove that this is equal to 0 matrix. It is given. Now in this condition, what is the value of small a and small b? So A square plus A into capital A plus small b into I, this is equal to 0 matrix. What is A square? 11, 8, 4, 3 plus A into A 3, 2, 1, 1 plus B into identity matrix 1, 0, 0, 1, that is equal to 0 matrix. Okay, so now 11, 8, 4, 3 plus 3a, 2a, a plus b, 0, 0, b. And 0 matrix, I will take 0, 0, 0, 0. Right, I can take this as a 0 matrix. So, taking it down here, 11 plus 3a plus b, 8 plus 2a plus 0, 4 plus a plus 0, 3 plus a plus b. This is equal to 0 matrix. So when can you say two matrices are equal? If all the corresponding elements are same. That means taking here 4 plus a equal to 0, that implies a equal to minus 4. And taking this 3 plus a plus b equal to 0, that implies b equal to minus 3 minus a, that implies b equal to minus 3 minus 4. So minus 3 plus 4, the value of b is equal to 1. Okay, clear? So what I did, I just found out a square, put down the value of a square, a and I, and just match the corresponding elements. And I got a equal to minus 4 and b equal to 1. So just note down question number 14. Now I'm giving you two extra sums. The first one is for a matrix A equal to 2, 3, 1, 2, so that A square minus 4A plus I2 equal to 0 matrix. It's not 1, 0 matrix. Hence, find A inverse. Right? It's similar to question number 13. Okay? 13 question, what we did? First, find out A square. Put down this in this LHS and prove that this is equal to 0 matrix. And to find out A inverse, take this equation, multiply both the side by A inverse and then find out A inverse. So you can take question number 13 as a reference. And second, if A inverse is this matrix and B is this, then find AB inverse. Okay? So there are two methods. First, find out inverse of A inverse. So you will get A. Okay, so now you have two matrices A and B. Find out the product and then find out inverse. Or else you can use the property that we did in that we had proved in question number 12. AB inverse is equal to B inverse into A inverse. You already had BA inverse. So only need to find out B inverse and take the product. That will be the shortcut. Okay? Clear? So just you solve these two questions by yourself. Clear? So students, that's it for today. In our next video lecture, we will continue with exercise 4.5. There are still few sums remaining. Okay, similar to those which we did today, but that will be in 3 cross 3 matrix. Today, we use this equation. We found out about this 2 cross 2 matrix. Now, in our next lecture, we'll be dealing with 3 cross 3 matrix. So today, that's it. Thank you.